G'day again everyone. Welcome to another edition of How to Become a Mathemagician. Okay, so today's lesson, what we're going to talk about is multiplying fractions, all the ins and outs to that, and also we'll have a bit of an introduction to improper fractions, what they are and how to work them out. Okay, so if you're new to this channel, be sure to hit the subscribe button. It's going to be really beneficial if you struggle with maths, find it difficult to understand certain concepts, or be able to show working out in a lot of different problems. Then this channel is definitely for you. Make sure you hit the subscribe button to keep up to date with all the latest videos we have here. Because what we try and do here on How to Become a Mathemagician is to show and explain to you guys a few different ways on how to work out these different types of problems, and most importantly we show all sorts of ways for you guys to be able to show all your working out, what that means and how to understand that, and yeah, that should hopefully be able to get you guys a better understanding of all these different problems, and also most importantly in an exam or a assignment situation you should be able to maximize your marks and get the most marks you can by showing all the different steps of working out. Okay, so we'll get right into this one. Okay, so basically, when multiplying fractions, what we're simply doing is multiplying the numerators together and then multiplying the denominators together. Okay, so it's different, totally different to adding and subtracting fractions, which is on a different video, which I'll leave in the description below for you guys to have a look at that. So with multiplying fractions, it doesn't matter whether the denominators are the same or common. We just simply multiply them together. So multiply the tops together and the bottoms together. But before we start, we can always look to simplify any of the numerators and denominators, and we'll explain what that means shortly. So here's just a bit of an example here where we've got 2/3, 2 over 3 multiplied by 3/4, 3 over 4. Okay, so the orange number here we've highlighted is the numerator. That's the number on top of the fraction symbol, and the fraction symbol actually means divide. So it actually means 2 divided by 3, and as this fraction. And the denominator is the green number we've highlighted here, which is the denominator here. So it's the number on the bottom of the fraction symbol. Okay, so what we mean by this when we're multiplying the fractions is just multiplying the numerators, okay, like we have here, be 2 multiplied by 3, and the denominators we would go 3 multiplied by 4. Okay, so we'll just show this working out here. Okay, so there's two different ways, or two different places you can simplify these. So you can try and simplify your fractions at the start, or you can do the simplifying at the end. Okay, so this first example here shows simplifying at the start. All right, so as you can see here, it's 2/3 multiplied by 3/4. Okay, so what we've been able to do, because 2 actually can divide into 4 as a whole number, so we've gone and done that. So for this numerator and denominator here, what we do to the top of a fraction we have to do to the bottom to keep it equal or equivalent. So the first step here we've done is dividing by 2. So 2 divided by 2 gives us 1. Okay, that's what we have this 1 here for. It's simplified down. And the 4, we've gone 4 divided by 2, and that gives us this 2 here. Okay, so this original 2 and this original 4 have now simplified into 1 and 2. All right, by just simply dividing both of them numbers by 2. All right, and then we've also gone and done the same in this this highlighted blue section here. All right, so 3 on the numerator divided by, remember the actual fraction symbol actually means and says divide by. Okay, it's a divide. So when we actually go and do 3 divided by 3, they simplify down to 1. Okay, as you can see here. All right, so we've gone 3 divided by 3 for this portion of the numerator, and that simplifies down to 1. And this portion of the denominator, once again, once what we've done to the top of the fraction, we have to do the same to the bottom, and then we go ahead and do that, and this original 3 here simplifies down to 1. All right, so it looks a little bit messy there, but then when we rewrite it, it basically just becomes 1 over 1 multiplied by 1 over 2. And then we follow the rule of multiplying the numerators together and the denominators together. Okay, so 1 multiplied by 1 gives us 1, and 1 multiplied by 2 gives us 2. All right, so 2/3 multiplied by 3/4 actually gives you 1/2 as your answer. Okay, now this is one way to do it, when you simplify your numbers at the beginning, okay, then perform the multiplication. All right, whereas this example down the bottom, it's the same problem, but we do the simplification at the end. So I guess it's up to you guys which you prefer to do. Either way is correct and fine. So I'll go ahead and we'll do the multiplication first before we simplify. So if we go 2 multiplied by 3, okay, that gives us 6, all right, as our numerator. And then 3 multiplied by 4 gives us 12 as our denominator. Okay, so we've gone ahead, done the multiplication, and we've come up with this answer. All right, now that answer is correct. 6 over 12 would be correct. Okay, however, quite often you'll be expected to give your answer in the most simplest form, all right, which you can gain a few extra marks by doing that generally. So what we do is we take our 6/12, all right, and we find the highest common factor, all right, between 6 and 12, okay, and that happens to be 6. All right, so once again, we've done a video about highest common factors and simplifying fractions. All right, I can also leave the link in the description below of this video if you want to check that out later in more detail. All right, but anyway, we've just gone ahead and found that 6 is the highest common factor between these two numbers. All right, so once again, what we do to the numerator, which we divide by 6, we also do to the denominator, we divide by 6. So when we go ahead and do that, 6 divided by 6 gives us 1, and 12 divided by 6 gives us 2. Okay, and as you can see, we end up with the same answer at the end of the day. This version here, we do any simplification at the start, and then we multiply the numbers together. All right. This way here, we just do it the other way around. We multiply the numerators together and the denominators together. Then we see what answer we've got and look to see if we can simplify towards the end here. Okay, so there's hopefully that makes sense. If you have any queries or questions, pop them in the comments section below, and I'll certainly get back to you to try and add a bit more information or clear some things up if you're a little bit stuck. Okay, so the next slot here, we've just got just a few more examples, all right, of multiplying some fractions together. All right, so this example here, we have 4 over 7 multiplied by 2 over 5. Okay, just some random fractions I've selected. And so just simply this one, we look, there's no simplification that we can do here. All right, so we look at the numerators and see if we can divide that into any of the denominators to simplify any of these numbers. But so between 4 and 2, all right, they are not anything common. They don't have any common factors without any of our denominators with 7 or 5. 7 actually happens to be a prime number, which only has factors of 1 and itself, 1 and 7, and so is 5. So with this one, we can do a quick check and see that we can't do any simplification at the start. All right, so then we just go ahead and perform the operation. So 4 multiplied by 2 gives us 8. All right, and then 7 multiplied by 5 gives us 35. All right, so that's all the steps of working out for this one. It's a pretty simple one. We just get our final answer here, 8 over 35. And like we discussed at the start here, there's no common factors here. If there's no common factors at the beginning, there'll also be none at the end. Okay, so the next example we got here is 1/4 multiplied by 3/4. Okay, so once again we can have a look at here. So our numerators are 1 and 3. Do they have anything in common with 4? No, they don't. We can't simplify anything from the top or the bottom here in this situation. So we just go ahead and multiply it out. So we go 1 multiplied by 3 gives us 3. And 4 multiplied by 4 gives us 16. Okay, so when you have 1/4 multiplied by 3/4, you end up with 3/16. All right. Now this one, this third example here is 3/5. Okay, 3 over 5 multiplied by 1/6 or 1 over 6. Okay, so just shown here once again to simplify at the beginning or the end. So this example we can do some simplification because we look at the numerators and we see we've got a 3 and a 1. Well, 1's already simplified. We can't get any simpler than that. 3. We have, now with our denominators, we have 6 and 5. Okay, so there's not much we can do with 5, but 6 we can. So 3 and 6 have a common factor of 3. The highest common factor they have is actually 3. All right, so we go ahead and simplify this at the beginning. So we have 3 divided by 3 gives us 1. All right, and when we have 6 divided by 3, okay, that simplifies down to 2. All right, so then when we go ahead and we go 1 multiplied by 1, we get 1 as our numerator, and then 5 multiplied by 2. Okay, so it's not 5 multiplied by 6 in this case because we've actually simplified 6 down to 2. All right, so just remember that. So it's 5 multiplied by 2, okay, which gives us 10. All right, so 3 over 5 multiplied by 1 over 6 gives us 1/10. All right, and we can also prove that that's correct over here. We do it the other way around. We simplify at the end. Okay, so if we have 3/5 times 1/6, we go 3 multiplied by 1 gives us 3. Okay, and 5 multiplied by 6 gives us 30. All right, so we have 3 over 30. So once again, 3 over 30 is correct. It is the correct answer, but you will be expected to express these in its most simplest form. All right, and that will also gain you some extra marks generally. So when we have 3 over 30, all right, we can look at the common factors between 3 and 30. All right, and the highest common factor we have between these two numbers is 3. All right, so we go ahead and divide the numerator and the denominator by 3. Okay, so what we do to the top of a fraction, we do the same to the bottom, and that keeps it equal and equivalent to itself. So when we do 3 divided by 3, we get 1. And when we go 30 divided by 3, we get 10. Okay, so as you can see, whether you simplify at the beginning or at the end, it doesn't really matter. You still end up with the same answer each time. Okay, in this case it was 1/10, 1 over 10. But there's two different ways you can go about it. Just so whichever you find easier or more comfortable, I would suggest you do it that way. Okay, very good. So far so good. So we'll go down here. So the next example we have here. All right, so this is a little bit of the introduction into improper fractions, what we mentioned at the start. Okay, so in this question here, we have 10 over 3, which in itself is an improper fraction, multiplied by 4 over 5. Okay, so an improper fraction, we just address that now, is a fraction where the numerator is a larger number or higher or greater than the denominator. So usually a proper fraction like this one here, 4/5, okay, is a proper fraction because the numerator is lower or less than the denominator, okay, whereas this one, the numerator is greater than the denominator, so we call it an improper fraction. And that just means there's actually incorporated into this fraction, there's already a certain number of whole numbers as expressed within this fraction, okay, because normally a fraction is a definition or a showing a portion of a whole, okay. For example, 4/5, it shows there's 4 sections out of the 5 sections available, all right, which is not quite the whole, all right. Whereas this one, 10 over 3, means there's certain number of whole numbers incorporated in here, and that's just what we've got over here. Okay, so the next step is to work out how many whole numbers there are. Okay, so if we go ahead and just perform this operation now, okay, so 10 over 3 multiplied by 4/5, 4 over 5. So we do the simplification at the start method, all right, because 10 and 5 have a highest common factor of 5, okay, so we go ahead and we divide the top and the bottom by 5, and when we do that, the 10 simplifies down to give us 2, and this 5 simplifies down, 5 divided by 5 gives us 1, okay. So then we just go ahead and we go 2 multiplied by 4, okay, that gives us 8, and the denominators, we just multiply them together, so it's 3 multiplied by 1, okay. Once again, don't make the mistake, we've already simplified 5 down to give us 1, okay, so it's not 3 times 5 here, all right, it's 3 times 1, okay, because we do the simplification at the start in this one, and that gives us the denominator of 3. Okay, so yeah, so our final answer is 8 over 3, or 8/3. Okay, so what we need to do here is to figure out how many whole numbers we have incorporated into this fraction and write them out separately, and then if there's any parts of the wholes or any fractions left over, then we write that beside the whole numbers. So I'll show you what that means, and we'll go ahead and do that here. So if we just make this one a little bit smaller to fit it all in. Okay, so there we go. Okay, so the denominator is key, all right, in any fraction, because it tells us how many parts make up one whole. Okay, so in this occasion, the denominator is 3. All right, so it just tells us for every 3 parts or fractions of it that we have, we will get one whole. Okay, so 3 parts will make up one whole for every one we have in this case. Okay, so one whole group uses 3 of the 8/3 available. So we have here 8/3 available with our answer. Okay. So we're just trying to determine how many whole groups we have. So this visual representation might make it a bit easier for you to see. Okay, so in this case, when we use 3 of the 8/3 available, okay, so we have our first whole number here, and as you can see, this is a whole. All right, it's got 3/3. Okay. All right, so then that's great. All right, so 3 of our 8/3 makes up one whole. Okay, so then we have another whole group. We'll use another 3 of the 8/3 available. All right, so when we go ahead and do that, we just do the same sort of thing. So another 3/3 here, all right, which is 3/3 makes up another one whole. All right, so far we have 2 wholes, okay, which is equivalent to 6/3. All right, as you can see, we've got 1, 2, 3. That's 1 whole. 4, 5, 6 makes up 2 wholes. Okay, and then so when we look at this and we see we have 6/3 we've used, and we started with 8/3 up here. All right, so that means there's going to be 2 more thirds left over. Okay, so we've just drawn this like this down the bottom here. So the 2 more thirds down here. All right, doesn't quite have enough to make up a 3rd whole. All right, so this is a visual representation. So 8/3. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8. All right, which is a combination of 6/3, which is these 2, and the 2/3 left over. All right, so we actually write our final expression in this case as a big number 2, all right, to represent the 2 wholes, all right, and then beside that we write the 2/3, the part of the fraction that's left over. Okay, so hopefully you guys can see that and it makes sense. So 8/3 is written, that's the improper fraction, all right, and then if we want to make it a mixed number, all right, which is this, it's got a combination of a whole number and a fraction, it's called a mixed number, and this is what we get. Okay, 8/3 converts into 2 and 2/3, and hopefully you guys can follow this and see how we come up with that there. All right, very good. Okay, so we might just end the lesson there. So that's an overview and a detailed explanation there of how to multiply fractions together. All right, and just touching on a bit of an introduction to improper fractions. Okay, so yeah, so thanks guys for your time. Yeah, hit the like button if you got something out of this and you found this useful. Make sure you subscribe to keep up to date with all the latest videos we have here, and we'll catch you on the next one. Great, thanks very much.